In this lesson, we're going to talk about radicals or roots. And the idea of radicals or roots is that we're going to undo the exponents. And so because we know that 3 squared equals 3 times 3, or 9, this means that we multiplied the 3 by itself twice. When I talk about the square root of 9, I'm asking for what number times itself twice, multiplied by itself twice, gives us 9. So this radical sign is our square root symbol. And that's just saying find what number multiplied by itself twice gives us 9. And since 3 times 3 equals 9, we say that the square root of 9 equals 3. So the formal definition of square root is the square root of a is the non-negative number x that gives us x times x equals a, or x squared equals a. The big key here is that we want a non-negative number because we want only one answer. So the only answer we want to the square root of a is the non-negative answer. So that's why we say the square root of 9 equals 3. We just want one answer. So looking at an example, the square root of 25 equals 5 because 5 times 5 equals 25. The square root of 4/25 equals 2/5 because 2/5 times 2/5, remember when we multiply our fractions, we just multiply straight across, so we get 2 times 2 and 5 times 5, and that gives us 4/25. So the square root of 4/25 is equal to 2/5. Now we could also do the opposite. So we could also say the opposite of the square root of 81. That's going to equal -9. And talking about order of operations, the first thing that we're going to do is the square root of 81. And then we are going to multiply by -1. That gives us the opposite. So the square root of 81 equals 9.
What, Daddy? What are you doing?
Because 9 times 9 equals 81. And so the opposite of the square root of 81 equals -9. The square root of 0 equals 0 because 0 times 0 equals 0. And 0 is a non-negative number. It's bigger than or equal to 0. So the square root of 0 actually equals 0. Now here again I'm writing the definition. The square root of a is the non-negative number x that gives us x times x equals a. So if I'm taking the square root of little a squared, I actually get the absolute value of a. The key information here is that the square root gives us a non-negative value, and absolute values are always non-negative. So for example, if I want to take the square root of -3 squared, this rule that the square root of a squared equals the absolute value of a, this tells me that the answer is the absolute value of -3, and that equals 3. Another way of doing the problem is to first compute -3 squared. -3 is squared is -3 times -3. That gives us +9, and the square root of +9 is equal to 3. We get the same value no matter which way we did the problem. So we do have this rule that the square root of a squared equals the absolute value of a, and the big thing is that we need to guarantee that non-negative value. So we can now simplify some expressions that involve both numbers and variables. So let's say we want to simplify the square root of 16x squared. Well, we know that 4 times 4 equals 16, and that last rule gives us the square root of x squared is the absolute value of x. So the square root of 16x squared equals 4 times the absolute value of x. If we want to check this, we're just going to take 4 times the absolute value of x times itself. Well, the 4 times 4 is 16, and the absolute value of x times the absolute value of x is the absolute value of x squared. But that just equals x squared because x squared is always bigger than or equal to 0. So the absolute value is really not necessary. We already had a non-negative number. Let's do another example. If I'm taking the square root of m to the 6th power, that equals the absolute value of m cubed. And what I did here is m to the 6th is m times m times m times m times m times m. There's 6 m's multiplied together. And when I'm taking the square root, I'm trying to find an expression that when multiplied by itself twice, so it's 2 groups, I'm going to get m to the 6th. So we need 2 groups out of these 6 m's. So that means there's 3 m's in each group. But because m cubed could be a negative number, we do have to use the absolute value here to guarantee that our answer is non-negative. So the square root of m to the 6th power is equal to the absolute value of m cubed. So a different radical that we can look at is called the cube root. And the cube root is undoing the power of 3, the exponent of 3. So the cube root of 8 equals 2 because 2 cubed equals 2 times 2 times 2, and that equals 8. The cube root of negative 1 equals negative 1 because negative 1 cubed equals negative 1 times negative 1 times negative 1, and 3 negatives multiplied together results in a negative answer, so I get negative 1 cubed equals negative 1. So the formal definition, the cube root of a equals the number x, or equals the expression x, where x times x times x, multiplying by itself 3 times, gives us a. One thing to note is that if a is positive, then its cube root is positive. If a is negative, then its cube root is also negative. The cube root of 125 equals 5, because 5 times 5 times 5 is 125. The cube root of negative 8x cubed equals negative 2x, because negative 2x cubed, remember our exponent rules, negative 2x cubed is going to equal negative 2 cubed times x cubed, and that equals negative 8x cubed. So we could simplify expressions for the cube root as well. In general, we could talk about the nth root. So the nth root of a equals the expression x, where x multiplied by itself n times equals a. If n is an even number, we must have both a being a non-negative number and its cube root, or its nth root, its nth root also being a non-negative number. If n is odd, then we either get both a and its nth root non-negative, or both a and its nth root being non-positive. If I take the fifth root of 32x to the 15th, this equals 2 times x cubed, because if I look at 2x cubed to the fifth power, I get 2 to the fifth times x cubed to the fifth, and our rules of exponents, x cubed then raised to the fifth power is actually x to the 15th. And that's how we do radicals or nth roots.